All right, good afternoon to all. So, we are nearing the end of uh, our semester on Com 8, Digital Comms. So, this will be the last chapter and set of topics para sa atong subject, uh, multiplexing or digital communication multiplexing. Included po here ang concept of line encoding, well, no, but not necessarily this afternoon. So, multiplexing, line encoding, yeah, basically mo to siya ang mga main mga subtopics na to for this last chapter. So, akong previous na activity for you was to create a notes on the different multiplexing techniques, right? So, unsa ito sila? Actually, daghan man, no? Pero, hindi ko sure kung pila kung nahatag nga ipapangita sa inyo, ha? So, ganito, do you have your notes with you? TDM, itong uban. FDM, SDM, ODM, CDM, and sa itong uban, WDM, haka ng last, I think mo na pasabutin mo, Clark. OFDM, CDM, 1, 2, 3, 4, 5, 6. Yeah, also OFDM. So each of these are, yeah, technically multiplexing techniques. We have time division multiplexing, frequency division multiplexing, space division multiplexing. So physical space, ang sabutan ni CDM is code division multiplexing. Wait. Sorry. Wavelength division multiplexing, and last but not the least, orthogonal frequency division multiplexing. So, do you understand the most basic concepts ani nila, no? The differences between each of them? Sabtan ba ninyo? Well, I'm not expecting discuss ninyo ang inner workings or mechanics for each, even ang circuit nor block diagram for each multiplexing technique. Pero yan gihapon nga lang simplified lagid bitaw, no? Simplified to the point nga ba differentiate lang ninyo on say differences sa each of these. Do you have makuha ba ninyo sa differences nila? So when you say time division multiplexing, definitely sir lahi gina siya sa frequency division multiplexing because makuha ba ninyo ang gist for each multiplexing technique? Let's say for example, what's the difference between FDM man and WDM? Frequency division multiplexing and wavelength division multiplexing. What do you mean when multiplexing? I think this term kinigawas naman ni siya sa logic na to, no? We have designed logic circuits using multiplexers or MUX, no? So all of these techniques has something to do with what, man? Okay, if you have answers, guys, or any one of you, pwede nyo type sa chat box. FDM kay simultaneous, yes, ang pagpropagate sa signals, but different bandwidth ang gina-occupy. Okay, so simply put, that's correct. So nai some sort of uniformity, or in this case, no, simultaneous way sa pag-transmit sa signal, no? So FDM is they are transmitted at the same time kay simultaneous man, but not the same bandwidth. Whereas WDM, same wire. FDM kay same wire maso, di ba? Ginaagihan but dili same path. Okay, actually correct na siya. Yeah, dili same path because different wavelengths sa signals. Okay, that's correct. So same ang wire. Specifically, I hope na sa inyong notes kung wala dala man idungag. When we say wavelength division multiplexing, ang media ginagamit ani is fiber optic. Okay? Fiber optic. Because sa fiber optics lang possible ang kanang statement kay gibutang ni Maui sa chat box na same wire pero dili same path, no? Kay kung atong nang hunaon-naon, how can that be? Nga isa ka wire sa lower ka piece of wire, so different path, no? So that's only possible through fiber optic. And di lang ko reveal much good in detail because next time pa man yung fiber optic communication transmission media man siya. So kaya kung atong i-think, di ba, wavelength and frequency are related, right? Related man sila. So lahan ko is ang speed of light man, di ba? Equal C over wavelength. Ano man lang ilahang kuan? Ang relationship. Frequency and wavelength. Yeah, F equals C over lambda. Sakto. So, F equals C over lambda. Lambda is wavelength. Yeah, sakto. So, at least para ma-differentiate na to ang wavelength division multiplexing from frequency division multiplexing. Well, remember nga, wavelength division multiplexing is, especially to you guys na yeah, we don't know if some of you may venture into telecoms, no? Basta WDM, fiber optics na siya. Pwede rin niya siya, metallic cable ang FDM. So when you say time division, multiple signals are transmitted at ang common ani nila tanan is same wire. Fakto ba? Same wire ba nila tanan? Or same medium, same physical facility? Am I correct? Yes, no, maybe. Ang FDM and WDM lang. How about the other multiplexing techniques? Well, actually, sila tanan except space division multiplexing, no? So ang SDM is rather unsophisticated form of multiplexing that simply constitutes propagating signals from different sources on different cables. So ang SDM lang. So space meaning different physical nga medium, good, no? Different space, physical space. So all of these entail transmitting signals from multiple sources in one singular piece of transmission media. So kung time division, at different times, no? So, I think nalaman sila sa ilahang name kung isa sa pag-label. So kung time division, same wire, but not simultaneous, kay different time man. So, ang FDM is same time but different frequencies. Ang CDM, ang code division multiplexing, is same time and same frequency. No? Same time and same frequency, meaning same bandwidth, but different ang codes for each signal. WDM, ako naman na-introduce earlier, different wavelength. So, light. And OFDM is rather more complex than all the previous combined, no? Would you agree? Mo ba yung pinaka-lisod i-subton sa tanan nila? Mo agree mo? OFDM? Yes, Mick.
Natuplok ka, sir.
Sige, kayo lang sa So, yeah. Ang OFDM actually ang pinaka-complex sa ilatanan because it will entail some sort of software, no? Or kung di man lang gani actual computer software algorithm. Mag-require siya Fourier nga algorithm para ma-implement. And well, in fact, ang OFDM ang pinaka-best suited for 5G communications. Muna ilahang ginatanaw. Actually, LTE mag-OFDM ang gani, no? Na multiplexing technique ang OFDM for 5G. I'm not so sure with LTE o OFDM ba. Ay, marag no, nakabasa mo sila po. LTE and 5G. So, muna future, no? Muna future sa communications. So, katuin nyo ang mga na-research na concepts. Those are very helpful for us to understand these topics. Okay. So, we'll start with an introduction to multiplexing. So, multiplexing is a technique in the physical layer. We'll understand this in a bit. What this means, no? Physical layer. Maybe we'd say, yes, of course, man yun, sir. Physical, man yun, no? Kaya mag-require ba siya og wire. Pero there's more to it than that, no? There's more to it than just the concept nga maggamit og wire o physical medium. Actually, this is a label. This is a label. Mas ma-understand natin later, kaning physical layer. Anong physical na siya. Whereby the simultaneous transmission of several independent signals from different sources is carried out. Simultaneous transmission. So, na some form of simultaneity. No? So, with multiplexing, there generally exists a priori resource allocation, and resource sharing is usually done within the confines of a local site. So, singular nga site, meaning singular lang nga medium, but over a single common communication channel. Multiplexing is done when the bandwidth of channel is higher than those individual sources. So, again, bandwidth of the channel, meaning ang medium, no? Wire, fiber optic, cable, air, and so the bandwidth of the medium is of course higher than those individual sources. At the transmitter, signals are combined while keeping them apart enough to avoid interference. Multiplexing is done by a multiplexer in the transmitter and demultiplexer in the receiver. So this multiplexer, conceptually speaking, is walay kalahian. There's nothing different between the multiplexer here and the digital multiplexer that we have discussed in logic circuits. And the same gyapon. So, mamaya ang mga general characteristics sa multiplexer, it has multiple inputs and singular output and selectors, right? So, daghang ways pag-implement sa multiplexing using multiplexers. So not to be confused with multiple access techniques. Okay. Um, because there are these multiple multiplexing techniques, time division multiplexing, frequency division multiplexing. We also have time division multiple access, TDMA, frequency division multiple access, code division multiple access, very popular, etc. Okay. So they are different. There are mas dagan og similarities. Of course, essentially, uh, there are numerous similarities between TDMA and, for example, TDM, no? And FDMA and FTM. So, nasa similarities. Pero we'll understand in the next slide, no? Sa ilang difference. Pero let's just remember, kay ma-encounter gid nato ni pohon kani nga terms, multiple access techniques, TDMA, FDMA, CDMA, etc. And let's not confuse it with multiplexing. TDMA uh, or TDM, time division multiplexing, is different from time division multiple access. Ang main na difference nila is uh, learn in the next slide. Ilang main difference. But ilang concept yun is basically the same. No? Sending of signal in one physical medium at different set of times. Mo na siya TDM and TDMA. So, common types of multiplexing are these. I think one of them atong gipang search. Diba? Okay. So, before I proceed, kuwan sa ko ha. Um, AFK sa ako kadjat. Kadjat lang yun. Okay, balik na ko. Okay, so yeah, again, lahi sila, no? I mean, nasa differences or main nga difference ang CDMA and CDM and etc. So before I go further, ako na sa ning introduce nga concept, the OSI reference model and TCP/IP suite. Have you heard this? Nakadug naman before. Yeah, abstraction ang abstraction noon slang duha. Oh, abstraction abstraction ni sila, yeah. Nakadog naman eh. Kisay nakadog na OSI model and TCP/IP. Nalabyan na to before. Okay. So, in a nutshell, next, pon pa man siguro ni. So, di ko sure kung saan nga subject ni siya. Sa computer networking man ni siya, basically. Isa sa mga problems nga ma-resolve ani is kanang the idea that that there are different vendors, no? Or manufacturers of different networking devices, no? So different networking devices, different vendors, differing vendors. Isa lang yung sa ako, dili man gini maugid ang main. Pero isa makasolve. Isa sa mga problems na ma-solve sa kanyang concept. Different vendors of networking devices. Okay? So, example, router. No? Example, router. There are different brands of routers. Big names na ito ikuan. No? Kaya na may mga generic type of routers. Not really sophisticated ones. Big name routers kay Cisco, of course. Cisco. Gusto mga sikat sa una. TP-Link. No. Kuan. Kanang Huawei. No? Huawei. TP-Link. Google. Nando day router ang Google. So, etc. No? Linksys, ASUS. So, we have different brands for routers. Now, lisod kayo if daghang manufacturers of routers. Again, this is just one perspective. This is dili gid siya mao ang main reason nga nung gi-develop ni. But it solves this problem. The problem of different routers, different companies creating routers. So, para na ay some sort of uniformity or standard nga i-follow. So, they came up with OSI basic reference model. So, this is just a model, a logical construct lang eh. But this is a standard, no? Standard na giset. Meaning, if this is the standard, this is the ideal model, ang physical implementation niya kibali karon, no? Is dili gid perfectly nag-fit sa OSI reference model. But close enough, no? At least close enough. So this solves now the problem of numerous manufacturers of routers. Para naslay isa ra gid bitaw ka basis. So not of course not only routers but all networking devices, even computers. So ang yang implementation is this one, the TCP/IP model. This is the currently used na standard for networking. So this is the implementation. TCP/IP. TCP, Transmission Control Protocol. IP, Internet Protocol. So the IP here is exactly the IP in the name IP address. So ang IP addressing is here, no? IP addressing. So TCP/IP. So bago sa OSI reference model, muna iyang 7. These are the 7 layers of the OSI layer. The application layer, presentation, session, transport, network, data link, and physical. So, kaning physical layer, aptly named siya because naapod here ang mga physical na medium, no? Physical media. That's why siguro physical ilang gigamit ka term for the physical layer because nadili nga layer ang physical medium. So, I believe that's the concept behind this statement, no? Multiplexing is a technique in the physical layer. So, multiplexing happens in this layer, sa physical layer. So, daghan man tag layers na ang next on top of physical is data link and then network. Okay? So, di na to iko ang gitanan, no? But these are ang kaning gray na column. These are the different protocols for each layer. Now, some of them you may be familiar, especially sa application layer. No? Application layer, nadi ang mga different protocols nga itong ginagamit when you communicate with one another. So, nadi ang HTTP, Hypertext Transmission Protocol. No? Kaya mag-open ka ng browser and gusto lang mag-access og site. So, ang protocol na gamiton is HTTP. No? Some of these may not be very familiar to us. So, lahi ang protocol for email, lahi ang protocol for instant messaging, lahi ang protocol for sending videos, upload, download, so on and so forth. So, nasa presentation ang compression and encryption. Nasa session ang mga session protocols, SQL, so on and so forth. Ilang mo ka back down sa mga words at sa mga letters ibang gamit. So, sa transport layer, ang TCP, UDP. Sa network layer, nadiri ang Internet Protocol, no? IP. Okay? Nasa data link ang Ethernet na protocol. Or simply put, kung ato na lang ta sa TCP/IP nga suite, routers belong to this level, to this layer, sa internet layer. Routers. Okay? Or layer 3, network. Whereas switches, network switches, familiar ang term? Switch. Dili ang switch nga mechanical switch sa sugaha. Kalaan ni siya nga device. Maybe some of you sa inyong mga balay na switch pagyapon ni gamit dili router. Familiar ni nga term? Switch. Kung itsura, mawala ni sila itsura. Router kay naman sumuha sa itsura sa router, no? Ang switch, mawala gyapon itsura ana, nagyapo yung mga RJ45 na ports sa likod niya. Nagyapo yung nga blink ng mga LED. Malagod gyapon black box sakto, no? Sakto. So, disem na sila. So, kana nga mga devices, sila ang kibali ga-handle sa data, no? Ga-handle sa information. So, ang medium, physical medium, is nadili nga layer, no? Nasa pinakaubos gid nga layer. So, physical medium, then switches, then routers, and then nadi ang computers, no? Microcontrollers sa computers sa application layer. Nadi mismo ang computer. PCs, smart devices. So, nadi ang user. A layer. Of course, sa gawas naman sa 7 layers ang user. So, again, multiplexing techniques. So, multiplexing techniques belong to the physical layer. Okay? So, multiplexing techniques na dire. And multiple access techniques, if I'm not mistaken, is nasa layer above the physical layer. No? Na somewhere here, a layer ang multiple access techniques. Yeah, so that's the main difference na lang. No? Kung i-simply state na to, the difference between multiple access techniques and multiplexing techniques is that ang multiplexing techniques na sa physical layer and ang multiple access techniques is nasa layer just above, no, the physical layer. Yan na lang. Pero ang concept is the same. Is probable gani nga inyohang especially katong to those of you nga nag-add og mga visuals, no, or drawings, figures sa inyohang mga cornel notes nga gi-submit. It's possible gani nga even if inyohang gibutang dito nga figures or definition kay sa TDMA, mag-work gani siya exactly for TDM. Kaya again, conceptually the same din sila. Lahi lang sila nga layer implement. Mora. Okay? So again, multiplexing is a technique in the physical layer. Multiple access, kani, somewhere above the physical layer. Above physical layer. So, wala lang, no? That's the only thing atong kailangan balaan for OSI and TCP/IP. Mabuto ta siguro ni pohon sa lahi nga com. So, these are different illustrations of multiple access technique, multiplexing techniques. So, kanin sa taas, ang pinaka-first, this one, kuan ni siya, FDMA. As you can see, it is plotted on the f-axis or the frequency axis, meaning frequency domain. So, if frequency domain, same time. No? So, pwede mo na siya doing lahi nga axis here for time. So, they are transmitted at the same time but different frequencies. So, dali na siya na to ma-imagine. No? Same time. Whereas, kaning B and C, these are, FDM lang ini, sorry. FDM. Whereas B and C are TDM. TDM. Ang isa lang ani is synchronous, ang isa is asynchronous. Synchronous ba ang term? Kanang, yeah, synchronous. Ang isa is asynchronous. So, when you say synchronous, example, we have 4 sources, no? Source 1, source 2, source 3, source 4. Each source has, let's say, for example, 3 bits, bit 1, bit 2, bit 3, so on and so forth. Meaning, ang pag-transmit is, ang first 3 set of bits is ang first bit sa each source. 4 man din ka source, no? So, yeah. This is the first bit of the first source, first bit of the second source, first bit of the third source, first bit of the fourth source. So, next nga frame, Actually, frame ang technical na term. The second bit of the first source, second bit of the second source, so on and so forth. So they are transmitted not at the same time, no? Same physical medium, but not at the same time. Ang difference lang sa synchronous ug asynchronous is that whenever the system detects na there is a blank, no, it will continue to transmit the next available na bit. Yan lang. So, dili necessarily nga synchronous ang transmission for all sources. This one, not necessarily last, ang D, this is WDM. Wavelength division multiplexing. Naka-indicate yun, optical fiber. Okay, sa optical fiber lang possible ang WDM. So this composite signal, isa lang ni ka-signal, okay? Isa na siya ka-signal. Common no? WDM. So it's possible nga sa isa ka physical medium, there are different signals, different wavelengths of signals. Yan na. This is an example of an SDM. Yeah. Space division multiplexing, no? Kaayo yan, naka-sophisticated because, well, multiple sources, multiple wires, no? Naka-pack lang sa isa ka containment. Whereas this one, MDM, multimode, mas pasabutan multimode division multiplexing. Multimode. So, possible lang again even ang WDM only possible with fiber optic because fiber optics could be made or manufactured with different, ang technical term is grades, no? Graded kibali ang kuan. So, ang density, unlike bitaw regular nga wire, no? Unlike regular nga wire, piece of wire, copper, or whatever, ang density is uniform all throughout sa wire. Whereas for fiber optic, posible nga kaninga part sa fiber optic has a different density. Kanila is like density. Lahing density here is here. Posible nga parehas lang og density. Yan na. Hence, it's possible to transmit different lights with different wavelengths in one physical piece of wire. Because fiber optics could be made with different grades or different densities. But sige lang, dili man ta mo go deeper ani because soon pa man nipod ni siya. For the context of our subject, I think we'll focus na sa TDM and FDM. So this visual actually is CDMA. CDMA. Pero kaninga figure works equally well for CDM. Now, whether CDMA or CDM, pareha lang nga figure ang gamiton. No? Meaning the signal or the information is transmitted at the same time. Okay. At the same frequency. But each source of information is coded differently. So, may coding na may tabo. So, yeah, each of these channels represent different sources. So, si channel 1 is given this code. Si channel 2 is given this code. So on and so forth. CDMA or CDM in which each channel is assigned a unique code which is orthogonal to codes used by other users. There's this term again, orthogonal. What does this mean? Na abot mo sa inyong notes sa pag-define aning nga term, orthogonal? Yeah. So correct si Maui. The degree of separation between the peak na voltage level, pwede naman voltage level. The degree of separation between the peaks of the two signals is 90 degrees. 90 degrees. Mali pa sa orthogonal. 90 degrees lang difference. Yeah. So each signal source for each channel is given different codes. So simplified lang sa atong pag-define aning CDMA. Okay? So again, even if di mo go deeper, using visuals alone, we'll understand the differences. At least ang differences sa lahi-lahing multiplexing techniques. So this is ako gilain siguro ni kay special mention siya. OFDM. So orthogonal frequency division multiplexing. So mag-utilize kaya po siya 90 degree na separation. Example here, the separation between this yellow signal and kaning pink fuchsia, no? Signal is 90 degrees. That's what we mean when you say orthogonal. So, orthogonal frequency division multiplexing. Isa po sa mga salient features is notice at each peak dito kay red, no? At each peak sa signal, kanila lahat is lang a signal. Each color represents different signals. They are again transmitted at the same time, but different frequencies, no? Same time but different frequencies. So ang differences sa each frequency is 90 degrees. No. So why is that significant? Because notice kani sa red na to ang red na signal. So muna yung main bandwidth, right? Kani muna yung main bandwidth. And this ako ha. What's proper term ani? Nila kani mga labit-labit. What's the proper term ana? Mga excess na sila. Nag-start sa letter H. Mga harmonics. Yung mga harmonics, notice na dili mag-interfere ang harmonics sa one signal sa main bandwidth sa other signals. So, i-compare na to si red signal kang black signal. Compare si red o si black. Sa peak ni black, here, 0 ang harmonics sa all the other signals. Walay signal nga gaana, kibale, no? Walay signal nga na voltage level when black is at its peak. No? So, all the harmonics, all harmonics of other signals are 0 at the peak of any signal. at the peak of the main bandwidth of any signal. So, dili mag-interfere ang one signal to the other. Pwede ganyan mag-cancel out ang mga harmonics, no? There's a possibility nga, example kanyo, si yellow o kaning si red. Pwede na sila mag-cancel out. No? So, pwede mag-cancel out ang mga harmonics. Pero dili mag-interfere ang mga na main bandwidth peak nga signal. So that's the beauty of OFDM. So it might sound easy, no? Easy to understand, but it's difficult to implement. No? So sa'yo na siya explain in concept, pero in detail, medyo complex din siya, no? Na ay some sources and some books na talk about sa kanilang topic alone, no? OFDM lang. Because again, this is a main player, no? Main technology in the implementation of 5G, OFDM. So I'm sure this won't be the last time na madunggan nato ni siya. Siguro this will be the last time madunggan nato ni siya sa atong subject, no? We'll not explore OFDM any further than this. So, then again, may encounter ninyo si OFDM pa more, no? Soon. So we'll start our discussion on multiplexing techniques with TDM, time division multiplexing. So TDM is a digital multiplexing technique for combining several low data rate into one high data rate. So from a lower data rate to a high data rate. Because di man sila i-transmit at the same time, dili man i-transmit ang mga kwan at the same time. So mahulog na whatever the data rate is for one source, then kung multiple channels na siya, i-multiply by the number of channels, mo dapat na siya ang data rate sa physical medium. No? In TDM, the available transmission channel is shared by a number of different sources. No? Time shared, no? Meaning not transmitted at the same time. The digital data or the digitized data from different sources are interleaved in time into a single digital data signal which is over the channel. The prime application of TDM is T1 carrier. Transmitting 24 voice signals. No? So 24 meaning ang T1 carrier has 24 channels. Digitized voice signal at 1.544 Mbps. Is this the first time na dunggan ninyo ning a specific rate? Familiar ning a number before? Kadumdum. Sige lang, Kiranil. basin bata pag gidaay mo, no? Kaya before, I think DSL na siguro to, no? Dito lang, type na. Pakitaan ako specifically. DSL, ADSL, SDSL, subscriber data link, kung sino yung SDL. DSL. Kadugong, pero kanang term ng DSL, nakadugong na mo, ana. Mo mo ng internet before. Digital subscriber line. Naa sa router. No? Aside sa naa sa router, ba? Naa ba? Nasa sa modem, siguro, I think, ang pasabot siguro nail, modem. I'm not sure sa router. Possibly, no? Modem. Because, ang DSL is internet access through voice channels, no? Or telephone. So, kanang familiar kani nga number because before mo ni ang gina-market nga speed sa internet, no? I don't know, maybe decade ago. 10, 15 years ago siguro. Di pa siguro mo conscious sa mga rates before. So, kay familiar ni because sa unang panahon pag yun, lain kay nga sa unang panahon ba kayo mga 20 years ago, no? I think elementary pa sa or high school. Ang pinaka-familiar sa amo nga term is 56. No? 56 kbps. Muna ang internet speed before, no? 56 kbps. Hindi pa yung nakaiman sa una. Connect na mo diretso ang linya sa telephone diretso sa system unit or kanang CPU sa computer o internet na yun sa una sa balay. So, muna yung speed sa una 56 kbps. Pas na rin ni guys, ang isa ka music ma-download og isa ka oras, lipay na kay may ana 1 MP3 file. Pila ka usa ka bugat ang isa ka MP3 nasa mga 3 megabyte, no? More or less. Mga decent ng MP3. Oh. Amo ning ma-download sa una og 1 hour, lipay na kay ko ka-download og isa ka MP3. Anyway, late na naggamay. So atong kuan. Pero ang ako lang is kaning 1.54. Skat kay ni siya nga internet speed. So a prime application of TDM is T1 carrier transmitting 24 digitized by signal at 1.54. We'll calculate later as nigi kaning 1.54. PCM is the most prevalent encoding technique used for TDM. So, tandem ang PCM with TDM. Tayo kayo, kung muna itong previous topic, PCM. So, PCM, TDM. How can I evolve? So, 2 or more voice channels are sampled, converted to PCM calls, then TDM. The fundamental building block for the most TDM systems at least in the US, and basically, kung asa man sa basis for the most parts of the world, ang system sa US, no, is the DS0 channel. So this is the block diagram of a DS0 channel, no? So as you could see, pareha naman sa PCM, no? Because exactly so. Ang one channel sa DS0, or at least ang isa ka channel aning asa man to 8, di ba? Ay. Ano lang, 24 channels. 24 channels. Ang kada channel ana is inganing itsura. So this one times 24 makes up the T1 carrier, diba? T1 carrier. T1 carrier. So this singular channel times 24 kabuok, that makes up our T1 carrier. So mo man ato na discuss last chapter, no? So ato lang ni multiply og 24, man may tabo. Diba? Channel 1, channel 2, 3, 4, 5, so on and so forth, until channel 24. So, exactly, 24 lagi kay ngani. Pero kung isa lang siya kabuok, well, di man gid siya ma-consider nga P carrier, kay maroon na siya normal nga PCM nga channel. So, we'll start with 2, no? 2 channel DS0. So, what happens kung natay duha ka channel? And ang key player here is the TDM multiplexer. So, muna yung multiplexer na to. So, what happens is, ang isa ka transmission slot, or we call that frame, diba? Frame. is divided into the number of channels. So in this case, duha lang man sa ning duha lang man ka channel ang example. So divide lang isa ka frame into two. Pero supposedly this is divided into 24. 24 channels. So channel 1, channel 2, channel 3, so on and so forth until channel 24. So pero para sugdan lang ang discussion, we'll start with 2. So what is this 125 microseconds? Ang nagikan. So 125 is the reciprocal of the sample rate. So of course the same ang sample rate for each channel. The sample rate is constant at 8,000 hertz. 8,000 hertz. 8,000 samples per second. Wait lang sa guys. Okay, again, sorry for that. So sampling rate is 8,000 hertz. So reciprocal sa 8,000, 1 divided by 8,000 is 1.20. Lagi 125 microseconds. So pwede nyo i-cons calculator ni. Is 125 microseconds. So what happens is, so sa isa ka second, 8,000 ka samples ang i-take. So let's say for example, ang first sample sa first channel ang i-take. Okay? First sample sa first channel. Out of the 8,000 samples. So napay 7,999 samples na bilin. So ang first sample is Example, 1011. Wala. Example lang siya. Out of 8,000 na siya kabuok, ah. Okay, let's say, for example, 0101. Na lang. So, 8,000 na kabuok. So, what happens is, here, sa output, kwaon niya, kung ano yung ilahi ng color, para, kuan. So, example, the same na lang sila, para di na malibog. What happens is, at the first instant, ang i-take ni multiplexer is ang first sample ni first channel. So after, ang next sample ni next na channel. Yan na. And so on, and so forth. Ayan na may tabo. So kani nga mga information, channel 1 na sila. Whereas kani nga mga information, channel 2. So magpuli-puli sila. So ang each frame, how is each frame measured? Each frame is measured, diba? So one frame na siya. So tanan samples sa kanang instant sa kanang channels will comprise one frame. So for a 2-channel nga TDM system, lang may tabo, no? So mo one frame. And this is, ang length niya is 125 microseconds. So naman ang 125 microseconds, nakuha na ang doka sample. The next 125 microseconds na pod, ang next na pod na sample, no? So at this point is 125 microseconds. At this point is the 250 microseconds. Such that mahuman ang 8,000 kaing ani, ay nahuman ang 1 second. So just like imagine kung saan siya kapaspas, no? So each sample, example, this is sample 1 of first channel. Sample 1 of channel 1 is divided into 8 PCM codes. So mo ni atong na-discuss before, no? So 8 PCM codes ni siya. Ay, wait. Okay. Yes, sakto. 8 bits man di ay ang per sample. Sakto. 8 PCM codes per sample. So ang computation here is 8, sorry for the noise, 8 codes or 8 bits per sample multiplied by 8,000 samples per second. That will be our lines, channel speed, channel rate, sa term, okay? 8-bit serial PCM code, 8 times 8,000 is 64 kbps. That is the rate for each channel. So 64 times 24 channels. 64 times 24 channels. 64 kbps man din per channel. Diba? Per channel. So we have 24 channels. Ilan na siya? Calculate na nato. 64 times 24. 1.536 Mbps. Yeah, line speed. Sakto. Sakto mo, line speed. So, 1.536. 536 Mbps. So, muna ni ang channel speed. No, wait. Sakto tong line speed. So, may term ani ha. Um, transmission rate. No? Ano ni ang transmission rate? Transmission rate na ni siya. But, abi ba na to 1.544 asa man to? So, muna itong illustrate sa next nga slide. So, notice here, this is what happens sa'yo. Muna ito siya ganina. So, kung duha ka, muna so, kung 24 ka buok, so 24 ka channels here. So, muna itong 1.536 Mbps or megahertz. So, mag-add po dito isa ka framing pulse. Add tag framing pulse. So, what is that framing pulse? So, what's the purpose na niya? The framing pulse is for synchronization purposes. No? Synchronization. Para mabalan sa receiver ang one frame from another. Okay? For synchronization ni siya. Differentiate one frame to another. So, paano wala na himong 1.544? So, yan na may tabo. So, remember tong 8K, 8,000 samples per second. 8,000, bits eh. 8 bits. Okay, bit man 8 bits dahil dapat. Dito 8,000. 8 bits times 24 channels. Supposedly there are 192 bits. Before na ito i-multiply sa sampling rate. So, i-multiply natin 192 sa sampling rate ng 8,000, 192 times 8,000, mo itong 1.536. But before natin i-multiply, kaya mag-add man taog framing pulse. So, plus 1. That makes it 193 bits. Then i-multiply yung 8K. 1 framing bit. So, 193 bits times 8K. Dahil ng atong the infamous 1.544 Mbps. So, ano siya ang transmission rate. Diba? So, simply, TDM multiplexing, TDM, time division multiplexing 24 voice band channels does not in itself constitute a T1 carrier. Pero mo iyahang basic na building block. At this point, the output of the multiplexer is simply a multiplexed first-level digitized signal. The system does not become a T1 until it is line encoded and placed on a special condition cables called T1 lines. So, ang essence behind T1 carriers is kani atong di-discuss. Pero, ayaw pa gid siya ma-finalize og tawag nga T1 carrier system if nahumana og line encoded. So, whatever this is, line encoded, line encoding, muna itong ma-discuss puhon-puhon, no? Ang mga, I think you've heard of these terms, and RZ, return to zero, itong mga other terms gani. And RZ, kana AMI, kana nga mga terms. Laon sa man na siya Lahi mo na nga RZ. RX. Anyway, so I have a matawag nga T1 digital carrier system is after all of this, no? After na-achieve na ang endpoint na to here, i-undergo pag-line encoding. And ipapasa to siya sa special types of physical medium called T1 lines. And for modern T1 carrier system, yan ang itsura sa each channel, no? Each channel. Kaya mo isa ka frame, no? Mo siya isa ka frame. Channel 1, channel 2, channel 3, so on and so forth, channel 24. No? So for each channel sa isa ka frame, ang itsura. We have 6 bits. 1, 2, 3, 4, 5, 6 for the information. Actually, apil man sa information ang sign bit. No? Ang sign bit, mag-determine naman kung positive or negative, pero part man siya sa information. No? So, nabot tayo, muna itong framing bit. Okay? But it's only transmitted at the in front of the very first na channel. Wala may framing bit sa all the other channels. So, kabantay mo din. Ano po, isa ka framing bit sa channel 1, sa next na po nga frame. So, this framing bit is at the beginning lang of each frame. So, 1, 2, 3, 4, 5, 6, 7. The last bit is the signal bit. The 8-bit or B7 signal bit. So what is the purpose of the signal bit? For signaling functions of telephone systems, like pulse tones, on hook, off hook functions, so on and so forth. So para ma-accommodate na siya ng mga functions, diyan lagi butang sa 7th bit. 8th bit, 8 naman din yung bit. So, muna ang composition sa PCM codes, sa 8 PCM codes for each channel, for each frame. So, if you'd like to know if napabani nga, exist pa ba lang ang mga systems, yes, existing pagyapon ni T1, our conventional telephone lines are still operated in T1, either T1 or T3. Common po din nga term, T3. T1 or T3 carrier systems. Buhay pa magyapon ni Slantod karon. That's why important gapon nga makabulota gapon ani. Kay we don't know. It might be nga some of you will land in telecoms. Okay? So far, any questions before we end? Understandable ba? Considering na may prior nga knowledge ani, no? Especially sa inyong Cornell notes nga activity. Any questions? Which one? Kani? Okay, notes. Kani sa yung pasabot. Para sa ba yung pasabot? Kani nga slide or kani nga slide? Kani siguro. Sige.
Ay, kadong ko answer, kadong isa, sir. Okay na.
Kani?
Yes, sir.
Wala mo isuot-suot din.
Ang kanang ko answer, sir, kay picture.
Picture. Okay. T3 naman. O sige, like nga T inyo na ilan ha? T5. Ay, lahat mo na siya. F4. Now, any more questions? Semi-fi. Um, wala pa mo naka-think. Sige na lang, kung ano lang na siya. Parang flexible na siya, Dre. Na, sige. So, no more questions. If wala na, I'll just upload this one sa e-learn, no, for your personal reference. And if there are none, yeah, thank you. Good na ta. Sige, dismiss la, guys. See you tomorrow. Okay? Oh, lagi tomorrow.
Thank you,
Tuesday.
sir. Bye, sir.
Okay,
Sir, bye, sir.
bye-bye. Bye-bye.